Hey everybody. Give me 2 seconds. I just realized that I need to change my stream title because I was working on my GoBot last night, and that is not what we are working on today. So give me 2 seconds. Let me update this. I always forget to change this. I guess that's the advantage to continuing to work on the same thing. Okay. Stream Manager. Edit stream title. Okay. Rust and GStreamer. Building an RTMP switcher. Okay. There we go. We're updated now. I lied to everybody who got a notification. So, Ryan, welcome, welcome, welcome. You get to ridicule me for my very terrible Rust code. Hey, we have a shout out now. For anybody who has not seen Ryan's channel, you should definitely go check Ryan out. Ryan is the resident Rust expert. So the challenges we're facing are, I did some refactoring yesterday, and so now we have different components for our mixer and our inputs and outputs, except GStreamer has this notion of these like inter-audio and inter-video sources in syncs, which allow us to basically wrap different parts of our pipeline in their own pipeline, and they call them a bin. So I'm overselling you. I don't think so, Ryan. I've seen your stream. So we're having this issue where our pipeline kind of breaks with these. And I know I've seen these used before. And I think that my understanding of them is just flawed. So what I'm thinking I might do today in the interest of time and getting kind of like a working prototype of this is I'm thinking about dumping this inter-audio, inter-video source stuff sorry, getting a text. So I'm thinking about basically just dropping that for now and then just having one pipeline. So let's look at one of the kids. Okay, so let's look at what the pipeline looks like right now, and then we'll kind of explain. So we got kind of like this mess of craziness here. I'm gonna just back out of it a little bit, and I'll just kind of give you a gist of what this is. So this is one pipeline that's decoding our URL and producing pads. Now this is our mixer pipeline, which has all of the encoders and decoders and stuff in it. And then this is another pipeline for the bin. And then it creates sort of like these, if we zoom in here, these inter-video and inter-audio sources and syncs, and then they're named by a channel. And then GStreamer kind of just like links them. But our pipeline seems to break with this. We're having these weird issues, and I feel like there's pieces that I'm missing, and we've kind of spun a lot on it. So what I'm thinking about doing is just making it all one pipeline. And Ryan's here, so he might be able to help me with what the cleanest approach to this might be. But we'll make it to one pipeline for now, and then I'll just leave it to do to come back and figure out what the issue with that is. So the issue with now that we have our inputs and outputs separated is that inside of our mixer, this is where our main pipeline is held. Now, in order for us to link anything, we have to add every element in the entire pipeline to the pipeline, and then we can start linking them. But now we have the issue that inside of our input here, we are creating a bunch of elements that need to go in the pipeline. So these two components now become basically coupled to each other. So my thought was potentially having just something like a function add to pipeline, and then we could have something like this, right? We'll add an error type. So this is my rough thought here. And then we would have like maybe like a link function. And then our mixer, we'll just go to our add input, for example, might do something like that, right? It might take our input and say add to pipeline and then pass in here. And then an input dot link or something, right? This is my rough thought. I don't like how coupled these kind of are to each other, but this whole inter audio and inter video source thing is also not working very well either. So, is that absolutely terrible, Ryan? I mean, I suppose we could just have one method and call it link, right? Oh yeah, we have the new party mode here too. Yeah, and that's my fear, right? However, this is like C stuff being passed up, so it doesn't really care that we make copies of this. We can do this to our heart's content. It just calls out to C anyway. And then inside C, there's a reference counter. So I think we could actually do this. Yeah, and I would much... So I think we can get away with doing this. I just don't like it because it doesn't feel like Rust code, but for now, this may be our only option. So let's gut this out really quick and let's see what happens. So we also would remove this. And this. And oh, we're gonna need to change this because it would really be, we would be linking our input.video and our input, video and our input.audio. What are we complaining about? Ah, me forgetting my semicolons again. All right, so let's just create one thing here for now. Let's get rid of these intersinks and crap too. Okay. Here's our pipeline. Why do so many breaks? Yeah, I mean, I don't think anybody's like developing websites looking at the dark reader. So I'm thinking maybe what we do is create an elements here, and we'll create a vec of GST element, and this will give us an easy way of cleaning up. So can we convert between those? Because this pipeline add, right? Can we convert between a vec and a I guess that's what, a slice of elements. Which at minus X clippy. Oh, those are private. Yep, we're gonna pull those out because we're gonna need those. You know what? Let's make this one directional. So when we say link, we're gonna give it the pipeline, and then we're going to give it nope. Let's give it its audio element and its video. Maybe. Okay, so what's cargo check just kind of does like a first pass on it. All right, so let's do this. And for anybody who's new here, please stop me if you're not up to speed on what we're building. And I can do a quick first pass. We probably will here soon anyway, as more people come in. All right, so in this case then we should, we need self here. All right, so here we're going to link self.audio, self.video to audio. Maybe? Oh, because we're not returning a result. I guess this would just be result. Ah. There we go. Mismatch type. Oh, because we're not returning anything. Okay. So we would also want to do this add many, right? Where did we put that? We sort of want this logic, right? So now,
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Anti-Gravity. If you're tired of typing, you can add type error equals in your file. Okay, let's do that. Type. So we're just aliasing it here. Equals box dine standard error error. All right. Did I get that wrong? What am I missing here? I have a semicolon. Oh, crap. Okay. So now we have, now I just need to look at this. So we have the vec. Can I convert that? Self dot elements dot. . as slice, right? As slice. So if I just do that, it borrows it as a slice? No. Oh, we need to remove that from the mixer first. We don't need this anymore. Okay, was it audio or video first? Audio. Audio, then video. All right, so here we want to pass in self dot audio. Oh no, we haven't created it. No, we have audio mixer, and then self dot video mixer.
It appears we have a new follower.
Thanks for the follow, Baziz. Is that how you pronounce it? Expected struct just because it doesn't care.
Someone finds you interesting, sir. It appears we have a new follower.
Crimson Emperor 19. Thank you so much for the follow. All right, let's see. All right, we gotta gut all of this stuff. All right, I thought that was gonna be a quicker refactor. All right, let's look at this. Because really it is our. We need to remove all of this. Let's see how we want to do this. Uh-oh, Ryan, you're tweeting? So we're going to have to refactor a bunch of this out, though. Oh, you're all good. I'm here to fail publicly so that other people can learn from my mistakes. All right, what am I missing here? All right, we don't need this pipeline. Let's comment these out for now. We still need this logic, because what this logic is going to do is, as the URI decode bin finds what type of element this is and what it needs to decode it, it's going to basically call this callback with each pad that it finds. And if you haven't been here, the way these elements are connected together are pads. So this is that URI decode bin. So this is our element. It'll recognize it has an HTTP source, and it'll build this sort of part of the pipeline for us, right? It recognizes that it's Matroska, it'll send it through a demuxer, and these are the pads that connect it. So as we get to the outside of this, when we come out of the decoder, our callback is going to tell us that, hey, we found a video X raw pad, we found an audio X raw pad, and we're going to leverage that callback to connect it to our part of the pipeline, which is going to do some conversion and things like that. So we need to keep this logic. So we need, on the other side of this, we need to connect our video queue and audio queue. Those are going to be the things that we're going to put. So that's what we want here. So our audio queue and our video queue. Those are going to be the GST elements there. We're no longer tracking the pipeline. Cannot find audio queue. Oh, I didn't name them with underscores. All right. We can remove this from here. Okay. So we're still going to have to link all of these things, which we had here. We don't want to link them till they've been added to the pipeline. Otherwise, we will get errors with that. So we need to bring them up here. So we're probably going to have to store all of these types on our input now too. Because the order that we link them is important. So I thought this would be a smaller refactor, but I guess not. We'll get there though. We fought the other way a lot longer, so this will be nothing. So we have audio convert, audio resample, audio queue, audio. These we don't need, because this will really be let's just rename these because these are all internal. So let's call it audio queue. Let's just put all of them here. So we've got audio convert. Then we have our resample. This will work well for us anyway because we might want to ask for certain properties or set certain properties on them later. So this is probably a good refactor anyway. Okay. So we have all of these on here. And we're going to do the same thing for video. So we have our video convert. We have our video queue. We have our, that's it. Because we don't need this intersync here either. So how complicated is GST programming in Rust compared to bindings like Python? I haven't used Python as much, but I mean, it seems fairly intuitive. I haven't really been struggling with anything that's like Rust binding related so much as been struggling with my knowledge of GStreamer itself. That seems to be my bigger issue is, you know, I'll have these things where I can play the pipeline and I can set it to an audio or video sync rather. And then, you know, it's just fine. But then I send it to an RTMP sync and I have all kinds of discontinuities. And then I have issues where like the pipeline works just fine as long as everything is in the same pipeline. But when I separate them out into their own bins and connect them with like the inter audio and video sources and syncs, then things just sort of fall apart, which is the whole reason I'm kind of doing this refactoring right now. I guess we don't need that anymore, do we? Because what we really should do is, I guess, we don't need to store it in two places, right? We can just do an and self audio convert, right? Audio resample, audio queue, video convert. Oops. Self dot video queue. All right. Struggling with GST. Yeah, I really want to learn it better. I would like to get down in the weeds with it a lot more. Wait, what? No field video convert. I see it. Oh. Because we have a typo here. All right. There we go. So that works. Oh, you have a WebRTC? I'd love to see that because one of the things I'd like to do in the future with this is introduce WebRTC to it. Okay. So here.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Polgo. Okay, so now that we have these in here, now we should be able to link all of these. So our audio queue is now going to go into the audio element that we passed in from the pipeline, from the mixer. And then this is going to go into video. We can get rid of that. And what error do I have now? Oh, right, because these need self in front of them. I keep hitting the wrong keys. Oops, and I put self in front of those. Ah! All right. Okay. Let's try that again. There we go. What are you complaining about? Unexpected token. Oh, oops. Okay, so in theory, this should all work. We now just need to come down here and set all of these things. So we had, I'm just gonna copy this for reference really quick. Okay, so we had, oh wait, that's right, because we can just use the shortcut here, right? Audio resample. Audio convert. Audio cue. All right, then we have our video convert. Video cue. I just adjusted the examples a little bit and it's running strong for years on ARM. Nice, nice, nice. Yeah, I have a lot of like big plans for this if I can get it, you know, working most of the time. But once I start getting into like clock synchronization issues and weird discontinuities where you really have to kind of understand the internals and the way the threading is working under the hood, then I start to kind of fall apart. And I'm really hoping to run into somebody who knows GStreamer a lot better than I do. Thanks for the follow, Henrik. Okay, so now we've refactored this. Let's, I don't even remember what we had in main. Let's go open main and see. Okay, so we had our RTMP that we were sending it to. Here's our URI. We're sending it to both. Okay, let's see what happens here. I don't know 100% whether this is going to work. Just because the output side is still in its own pipeline. Pipeline add many. Oh, wait a second. Wait a second. What am I missing here? Expected slice found struct standard vec vec. Input line 21. There is no vec there. What are you talking about? Oh, that's... Haha. Input link on 163 on... Right, self.pipeline. Right, okay. Self-pipeline, which is behind a mutable reference.
Intruder alert. An unauthorized connection has been detected.
Begin, welcome. We are in mid-refactor of our GStreamer stuff. So I'm hoping to get kind of something running here in a second. Welcome, Raiders. If you haven't been here, we are currently working on... Yeah, we built the party functionality last night. So what we are working on is an RTMP switcher. And the idea here is that we can have multiple like people submitting over OBS or whatever to some RTMP endpoint. Our switcher is going to come out, fetch RTMP, and then send it to one or more outputs. And these could be videos, these could be RTMP endpoints. And the idea is so that we could have, say, multiple streamers and we could just keep switching between them. Go to the host, let them intro a speaker, switch to the next person. We can layer things in. We can put transitions. We could do lower thirds. We've got a lot of ideas. I'm happy to walk through kind of how all of this stuff works if anybody has questions, but this is sort of the general idea of what we are trying to build. It's behind a mutable reference. I don't think we need a mutable reference here though. Oh, we do because we're updating the pipeline. So do I care about that?
Sir, it appears we have a new follower.
Thanks for the follow, GStreamer. What's insane? Can it be, then sell it to Twitch? It will be completely open source. Begin. That's, you know this. This is how you make all of the money. You open source the software, you give it away for free, and that's how you become rich. So you could have more than one of these. Yeah, absolutely. I mean, you could definitely do this. This will all be containerized and running out in the cloud somewhere. And these will each be spun up because we don't want anybody pushing to the switcher. A well-designed distributed system does not get pushed to, it pulls. It's declarative state, so it will know. We don't have the old diagram, but the other thing that would be built as a part of this is a scheduler so that this switcher will automatically say at 1 p.m. streamer 1 goes on. At 2 p.m. streamer 2 goes on. If streamer 1's bitrate drops for some period of time, fall back to a pre-recorded version of their talk, seek to roughly the same amount into that video that they were into their stream, and then push that out. GitHub stars, exactly. The GitHub stars, that's what's worth all of the money. I know the RTMP protocol, it's kind of hard to come by properly working open source RTMP solutions. Yeah, so this is why we're using like GStreamer and FFmpeg and stuff like that. Would be very neat for Glimesh as well. I'm not familiar what that is.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, VGavs. Okay, so we have a mutable reference, but we don't want a mutable reference, right? How do we solve for this? Do we do a .clone on that? Is that really what we want? No. Oh, because it's the same thing. So I think this is what we want. And then we push the work into C. Okay. So let's see whether this, I don't know whether this pipeline is going to work. Part of the reason we're doing this refactor is this. Value used here after move. Oh, right. Because we have, we need it here, video convert and audio convert for when our pads get linked. Why is it only complaining about, oh no, it's complaining about both of them. Let's see, how do we want to solve this? Well, I mean, we can clone these. There's no harm in these because just the way the G object works, it's just going to have its own reference counter. Or maybe not. Oh, right, because now we can't do that. We have to put the label. Borrow of moved value. Oh, because we can't do it there. We have to clone it up above. Yeah, so on the C side, Musin and a couple of the other folks that know C and all the G object stuff better than I do went on like a spelunking mission one day and discovered that that's all sort of done down at that layer. So we need to create our versions of them here. So let's call it audio. Let audio equal audio convert dot clone. And then we'll make this one video. All right, and now let's come down into here where we're trying to get the pad for it. Where are you? There we are. So now we'll just connect that to audio and connect that one to video. And then we try again. Are you going to work? Okay, we are stuck in the paused state. Why are we stuck in the paused state? Let's, I'm going to remove the RTMP one. That one tends to be problematic, especially while we still have that inter audio and video source stuff going on. We're still stuck in the pause state. All right, let's generate our graph for it and see what's going on. Graph is pause.svg. Okay. Let's go see what's going on. So this is still... so this is base 16 default dark. I use this for a lot of stuff. Okay, so are we not connected? Well, let's try this. Let's remove our input really quick. Main. No, we're gonna leave this one. Let's remove our input. And this should get us this steady stream that we have running behind the scenes. And that's left there so that we can detach and reattach stuff. Okay. So that's working. So there's still something wrong with our input. Now the question is, does it work going out to RTMP2? Is the issue with our input? Okay, so the issue is our input. Let's check this real quick. So I just have this like video and audio like test source playing in the background, and we're using a compositor to layer our video on top of, and we're basically setting on the test audio the volume all the way down. And the reason for this is just the way GStreamer works is we have to keep constant data flow from input to output, and if at any point we completely break the chain, then the pipeline will shut down. It'll end up going into a pause state on us. So we basically create a compositor where I'm going to change this to a different one where it's just a black screen, but we have this here just so that we know it's working. And then we'll layer our video on top, and you never hear the volume of the test source. So our issue is definitely with our input. So let's go look and drill down into this diagram. So here's our video test source and audio test source, right? We can see, okay, so this isn't getting connected. But you can actually look at this on a diagram, right? So we have our test sources coming in. We're converting them. We can see the scaling and resampling taking place, the queue, and then we can see our Syntel video and our test source coming in to the compositor, and then we have a single output coming out to a caps filter, which is just ensuring that we're setting like the frame rate and things like that we want. We see our audio getting mixed together. Same thing, Q. These T's are here so that we could actually send it to multiple outputs. So we're going to do the same thing on the other side. And then we have this inter-video sync, which is like magically getting attached to this whole thing, this inter-video sync based on these channel names. And that's how it's going out. So our issue is definitely in our linking process with our input. So let's go. Did anybody see the URI decode bin for that? It's not in here. Okay. So that's not in there at all. So where is our add input logic? Let's go to our mixer. So in our... Ooh. Is our issue the clone? Maybe the clone does not work the way we thought it would. Oh, wait a second. We never do all of this. That source never gets added in there, which is crucial to all of this. Okay, so now our source is in there. And that's why it never... Okay, that's our issue. Although, why does the link not work? Oh, okay, wait. So this is why. So every other thing has paths that are always there, right? This audio convert has a source and a sync, and we're telling GStreamer to link these things together. However, our URID code bin does not have them there. We don't know what they are. That doesn't get discovered until the pipeline tries to do something with it. We never added the source to the pipeline. So... Okay, so we are in the playing state now. Oh wait, did we... Alright, let's add Syntel and see what happens. Okay, so we're still in a pause state, but we do see our link take place. And I want to try something really quick. Let's remove the RTMP out. Because this one is problematic right now. And once we get it into the pipeline, I think we'll notice. Yep. Okay. So we have video. So now the next thing we need to do is refactor our output to work the same way. All right, let's do it. Oh. So we do sort of have an issue here where we're assuming that all of these things exist.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Gloska. Okay, so we do have an issue here that we're going to have with our inputs too, is that these elements may differ based on the type of input or output.
It appears we have a new follower.
Thanks for the follow, Fubaz Bar Cukes. So Dr. Dumenberg, you just have to say the color, and it assumes all if you don't specify where you want it. Yeah. Why is that not working? Oh, wait a second. Let's fix the bot real quick. We were playing with a new thing that set restrictions, so like I can't even set stuff myself because I'm not a follower. Okay.
Someone finds you
Now we can do it.
It appears
We can
have
say
a new
hue,
follower.
blue, electronics. Boom. Well, you can say hue, green, desk. Boom. Okay, so I think we're gonna have to make multiple output types here. And so this is where we get into like traits and things like that. Ryan, are you still here? So here's what I'm thinking. Because these are so vastly different, I think we probably need to do like an RTMP output and
Sir, please. It is not only your reputation at stake
auto
here.
output,
Do be careful.
something along these lines. But I want to be able to create a trait, which I have not learned how to do yet, so that my mixer can just have an output type or an input type. Thanks for the follow, Bernard. Do I want a trait or an enum? Ooh. That's actually a really good point. Because then I would be able to match on the type, right? So I could just say, is it enum output? And then we would have auto, and that would contain an auto output. Is that the right syntax for this? And then we would have RTMP. Output. Yeah, I like that. I like that. Okay. Well, I was going to say, because then we can't enforce that it has that, like, add to pipeline, right? Because we have inside of our add input, right? We have this link function. So it would be nice to ensure that it has a link and probably an unlink too, right? You can add methods on the enums? Really? So I can say impl output here and add a function on it? No way. All right, I like it. Okay. So all right, I'm just thinking how I want to implement this now. So this would be an this would be an RTMP. Well, this is already in the output module, so really shouldn't this just be RTMP? Because it's already going to be scoped as output RTMP, right? Okay. So this is RTMP, and we need to borrow part of this because this is actually going to go up here. Wait. Impl auto. All right. this up here. I guess we could just call this new now, being we're doing it very specifically for that type. Then we could do the same thing for here. This would be new. Okay. So then that would also mean that inside of our mixer for our add output, we're gonna have to go back and fix this for our input. Oh, it's already called output here, so that would be fine because that's the name of the enum. Okay. Okay, so let's, we're not gonna worry about our RTMP for right now. Let's just comment that out. We'll work on refactoring one at a time. Okay. Right. Auto RTMP. Okay. And we needed in here, we need a pipeline, which is a GST pipeline. We need audio, which is going to be some kind of GST element. We need video, which is going to be GST element as well. You can't access fields on enums though, since they don't have fields. You need to add methods for that. Right. But I think all I really need right now though is like this. Don't collapse me. Okay. So this is sort of what I'm thinking, right? So we'd have our unlink function here, right? I need to bring in that alias. Okay. Cannot find type pip line. Okay. Oh, and because I copied it, same issue here. Okay. Oh, yeah, I keep forgetting about that. And there's also the unimplemented, right? Right? What would be the benefit of unimplemented versus to do? They're the same thing. Oh, and for anybody that came in as part of the raid, shout out to Ryan Levick here. He is a coworker of mine, and he is the resident Rust expert here. My job is to fail miserably and make him look good. Let's all participate in getting Ryan a raise. Okay. So, and Ryan streams. I should point that out. Streams on a lot of Rust topics, and I have watched a number of them to learn concepts. Thanks for the follow, Mr. Wolf. Okay, so here's what I'm thinking. We have like this link and unlink, and that needs to exist on every output and input for that matter. So now do I have to do a match here on self to figure out what type I am? Okay. So the only way to generically be able to say, you know, self dot. Wait a second. This is actually and self, right? We need that. So we are building an RTMP switcher so that you can have one output to video to some other RTMP live stream service or more, So we can basically have multiple inputs, multiple outputs, and shut down and start up different outputs, or switch live hot swap between videos and live presenters, and then send them all out to the same place. We have a particular use case at work that we're going to use this for, as well as we're currently in the process of planning GopherCon virtually and trying to build that. I wonder what comes up on this link now. Does it bring up the old diagram, everybody? Or did we break it when I went through and... no, it looks like it still works. Okay, perfect. And then I have another diagram that it won't let me get a link to, which has a little bit more internals of how it works. That's this one that we're working with. Okay. So where were we? Match self, note the lowercase s. Yeah, so I commonly see this, like when you're trying to return, like say yourself here. Is that because capital S represents the type of self, and then the lowercase represents the actual receiver? Okay, then that makes a lot more sense. So this isn't going to work though, right? Because the type here is the enum, so we'd effectively be calling ourselves recursively, right? This doesn't get me link on the actual, say, RTMP output. The hot upcoming talk in GopherCon 2020. I don't know. There's a lot of really good ones. Did we take the agenda back down? I think we might have. Well, we reconfirmed that the dates worked for everybody, but we'll have that back up. Okay, so I really have to do match self, and then say, what would it be? Auto? Does that work? Right? Is this what we're doing? Oh, I have to fully qualify it. Output auto. I guess, yeah, we want this to be an expression because link should return back a result. And it does. Oh, we don't have it here, but okay. So if we implemented link on here, we're going to have a lot of refactoring to do. So if we implemented link on here, passed in self as a receiver, and then we have a pipeline, and then we have, that is a GST pipeline. Then we pass in audio, which is a GST element. And then we pass in video, which is a GST element. And then we return a result with a unit type, or unit struct, which I still don't fully understand what the crap that is yet, but I know that we use that one of those when we don't care about the actual return value, but we still want a result type. Okay. Unimplemented. Okay. Okay. So you never see an instance where there's something in between them. It just is its own thing, like a blank identifier or something. Or in the case of Go, it would just be this, right? Or this occupies 0 memory. It's just used as something to signal, right? It's basically the same concept. Because you'll see in Go where people will pass, down a channel this. Which you can't really put anything in there because it has no fields. So it effectively takes up 0 memory. So, okay. If it works like that, then that makes a lot of sense. Okay. So there's our link. Our unlink is going to look exactly the same. Well, I guess that brings up an interesting question. If we have passed all of these things in, should we do it again? Should this just be unlink? Because we can save these. I mean, it is not very Rust-like to do that, but using the underlying library, there's nothing wrong with doing this. Do you have feels here, Ryan? Because I know that if we do this, we have to hold references to these things. But does that matter? Is it effectively the same thing as if we had passed in an arc or something here? It's also used to represent that something happened and you don't need to return something, right? Yeah. Okay, so let's look at this. So here's our auto. Let's go with refactoring the auto one first. I guess we're gonna have the same thing here, right? Why are you indented in so much? Oh, and why do I have a semicolon back there? Alright, what are you complaining about? Cannot find... Oh, wait. Cannot... How many times am I going to type pip line? What is wrong with me? Y'all are just letting me sit here and typo. Okay, it should be fine if it's all reference counted. Okay, yeah. Alright, so what is this complaining about? Let's just do a cargo check real quick. Cargo check. This is all in the mixer. We'll fix that later. Output auto does not have this field. Line 67. Oh, because we haven't done all of this yet. So okay. Pip line counter. Pro tip, read the error messages. They are all good. I think most programmers have learned to not actually read errors since most languages don't actually give you. Yeah, that is one thing I really like about Rust is it, like, in addition to how many programming languages point to the legitimate line, right? Most of the time the compiler fails on like some later line because it's something you screwed up here. So the fact that it gets you to the line most of the time that you made the mistake is already a win. Then the fact that they point to the part of the line is another win. And then when they recommend, like, hey, if you just add ampersand, this probably fixes it, dummy. Even better. Okay, so we need a name here. And I think we were doing string. All right, so pub, name, string. Okay. Expected. Oh. Okay. Now here we need to get rid of all of this. So we don't need the pipeline. We don't need all this inter crap. We don't need all of that. We need our video sync and audio sync. So this is going to be video sync, and that's going to be a GST element. And then we need an audio sync, which is also a GST element. And what else do we have? Audio sync. Video sync. Alright. All of this needs to go away. We're going to fix all that here in a second. What is this? Cannot find pipeline in this scope. Oh, because that's leftover. We're not tracking the pipeline anyway. Okay. Cannot find value video sync. Ah. Cannot infer type from parameter K. This is all in our mixer. Private enum. Ah. We need pub enum. Okay. Okay, so this is all going to be in our mixer. Yeah, we're gonna have a lot of refactoring to do in our mixer. We know that. Variant or associated item not found in. Oh, and that's in main. Okay, so let's go fix main really quick. So we need output. How do we do this? Is it output auto new? Does that work? Failed to resolve auto is a variant, not a module. So we need to do what? We need to do output. Is that how that's going to work?
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Sal. So we have output. Yeah, so why would that not work? Expected function, tuple structure, tuple variant found enum. Well, I tried that before and that did not work. All right, hold on. Let's back this bus up. All right, so we have output. You're just watching Vim users? That's your Oh, that's right, because I need to actually do output auto. Wait. No, I need to do an auto new, right? Yeah. That's where I'm messing things up here. So this should really be output. Nope. Well, oh, right. It's like, I'll get it eventually. Okay. So that works there. Now we need to go, now we need to go check our, mixer. Because we got a lot of problems in our mixer. I guess we start at the top. Line 180. All right. Mixer, what do you got going on? Line 180. So we cannot get the name of it. Okay, so let's go to our output here. And we need main. And you are going to return back just a string. We should be able to just say a.name, right? that error? Cool. The problem with Vim errors is they are limited, not showing the full error message. You need a way to easily see the full error message from Rust and Vim. Yeah. Always trying to figure out what little thing they know that we don't know it's real. What are we talking about, McCann? Are we talking about Vim users? All right. Let's clear that. This is all in Mixer. Help use parentheses. Okay, right, yeah. So we fixed that. All right, we're gonna just have to find all of these cases where we do that. Why is that still? Oh, because name is private. Pub. There we go. And we know these need to be pub 2, so let's go ahead and make them pub 2 because it's just going to yell us here soon anyway. Okay. All right. Yep, we are going to get rid of that. And we don't really need that to string because it's already being returned as a string. Okay. And this whole thing... All right. The more I see the code, the more I think that maybe using a trait was the right way to go. Sorry, but it works with enums too. Yeah, the more we're kind of doing this, the more I'm sort of looking at it like there's a lot of kind of copy and paste here. So we haven't fixed Mixer yet, so we aren't too tied into this, and the things that we have fixed are probably going to remain the same. So how do we go to the trait route? Let's see. Fix Mixer first. Okay. Okay, let's see. A name has type center, which does not implement the copy trait. Huh? Move occurs here. Well, I don't think it matters, right? We can just do... All right, Ryan, thanks for hanging out. I'll show you what it looks like once we get all the refactoring done. So I think that's really what we want there. Where's our error? All right, because the match has to be explicit. Okay, so we're gonna copy this. We're gonna comment that one out for right now. Okay, so this works. Let's fix our mixer, because now we sort of have like all this broken stuff. So we do not want all of this inter crap. Let's get rid of all that. It's been like the bane of my existence. All right, we're gonna get rid of all that. And we're not gonna do any of the linking here. All right, we are going to call output.link, and we are going to pass it self.pipeline.clone, right? And then self. Audio mixer, and then self dot video mixer. Right. Found. Oh crap. Do we even need that clone? Oh, we're going to, because it's a mutable version. So this is still gonna complain. Or maybe not? Do we... Okay. No, I was right. It does need the clone.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, unknown3122. Okay. Input link pipeline add many. Okay, so where's our input link? Let's go ahead and remove that, because that's as simple as adding a question mark. So we might as well do it. What else do we have? On input line 23. All right. Okay. You love bald people? I'm not there yet. I'm trying hard. And, you know, I probably got a few more days and then I'll be bald. It's happening that fast. Associated function is never used. Just as a bunch of warnings. We'll fix all of this stuff here later. So let's see whether this works or whether we broke everything. Ooh. Thread main panicked at not implemented. Oh, right, because we never actually implemented our stuff here. So we need to take all of this and come into our link function, and we need to call pipeline, and we need to add our audio self dot audio sync and self dot video sync, and then that is it. So now those are added to the pipeline. Now we need to link their audio coming in and their video coming in into our syncs. Oh, what are we yelling at now? No field audio inc. Nice. Audio sync. Okay. Mismatched types. Oh, because we need to return something here. Okay. Find value audio sync in this scope. Oh, that's because it's self dot and self dot. Okay. There we go. That's what Rust will do to you. That's what GStreamer will do to you. Failed to link elements. Okay. So let's figure out our issue here. I'm gonna close that for now. Okay, so we're passing in the audio mixer and the video mixer. That's what we want. No, that is not what we want. We need the T. The T. What? No field audio T on type mixer. Oh, we call them out. That's right. Audio out. Video out. All right, now let's try this. There we go. Okay. So now we haven't implemented our RTMP one yet. So let's go ahead and fix this first, and let's convert this to a trait. I know nothing about implementing traits, so we're going to learn this one together. So let's go find the Rust book. There we go. Traits. Defining a trait. Okay. Okay, so we just need pub trait, and then it has functions in it. Okay, so that's not bad. So then we would just call this a trait, right? Output. And then we're just going to say it has methods on it. So pub function. Oh, I guess that would be it right there, wouldn't it? So that. Okay. And then we also want a link, right? Do we comma separate these? Is that how that works? Yep, okay. And then we would just have a unlink, right? Is that right? Alright, well, let's see. Let's run a cargo check here and see. Oops. Well, we know about all of those. Where's our issues with output? Expected semicolon or... So do we not separate those? Yeah, so they have to be. Do we semicolon separate them? No. I'm so confused right now. It only gives us an example of a... Yeah, there's a semicolon there. Oh, we don't put the visibility on each method. We only put it on the trait itself. Okay. There we go. So this would be impl output for auto, right? No, we don't need all of this. That all goes away. And this would be impl output for auto, right? Unnecessary. Oh, right, because the visibility is on the trait. Is not a member of trait output. Oh, wait. Okay, so we've got two issues. Okay. So we do need this. So this is going to be our impl auto. But we need down here, we need impl output for auto. And this is where we're going to implement our link and unlink. Okay. Is that it? Okay. So that should work. The trait output cannot be, wait, hold on. The trait output cannot be made into an object. So, right, so we need to, this is gonna be like a generic function then we're gonna have to take. All right, let's see. And then we put constraints on it, right? Okay, let's see. Let's see. There we go. Okay, so we just do an and impl. I guess I always saw it as a generic thing. Well, it looks like here, so now that you know how to define and implement traits, we can explore how to use traits to define functions that accept many different types. For example, we implemented the summary trait in the news article and the tweet types. We can define a notify function that calls to summarize, blah, blah, blah. To do this, we can use the impl trait syntax like this. Okay. But it also says, instead of a concrete type for the item parameter, we specify the impl keyword. Okay, this parameter accepts any type that implements and specifies. And then nobody of them. Okay, we can call notify. So this is the way I've always seen it, the trait bound. The impl trait syntax works for straightforward cases, but is actually syntax sugar for a longer form, which is called a trait bound. Okay, so this is the way I typically always see it. Okay, so which way should we do it? Should we say and impl here? Or do we use the trait bound? Okay, cannot be made. The trait output cannot be made. Oh. So that's going to be a tricky one. Line 62, we can use a dyn output. Dyn output, does that work? No. Cannot be known. You lied to me, Rust compiler. You lied to me. You said put dyn there. So do we need to use a box here? Is that what we do? It's a box dyn output. Well, I don't think we can use impl inside the hash map, right? Because I'm pretty sure we can't just say, you know, impl output here. If this works, yeah, I didn't think so. So let's see. Rust, hash map, trait. How to add trait value into hash map. Okay. What say you? That's what I thought. Oh, wait, wait. So it looks like everybody else is using box. That's what I thought. So why does box not work for me? Why does it not like me? Trait objects without an explicit dyn are deprecated. But I put that there, and it says output cannot be made into an object. Well, I still get the error here where it does not allow me to do that at all. Some of these are kind of like years old, but oh, I may have hit that one too many times. So do we blow away our ability to store it in a hash map? This is all like implementing their own hash map. That is not what we're trying to do. What's funny is I'm pretty sure I just saw a YouTube video where Ryan did something just like this. I'm running into one of these. Let's see. Yeah, yeah. It appears so. This is what I'm running into. So, how do we store generic types then? I guess I must be separating the idea between traits and generic types. Well, because the generic type we get like monomorphism, right? Where it's just generating new versions of the function. But how do we determine that we want to store some interface, which is effectively what a trait is, right? I know I've seen this too. And I'm not really sure what our alternative is here. What you got, Vega? Returning traits with Dyn. Yeah, so this works for returning them, but how do we store them? And that's what I thought, was that we could use this box, right? That's how we return it. But it doesn't seem that we can use a box to store it. So I mean, this would work for that one, but that's, well, cannot find trait auto in the scope output auto. Well, no, because that assumes a trait, right? And auto is not a trait. Output is a trait, right? All right, we already imported it. It's just output. So I'm not 100% sure what this means. Output cannot be made into an object. But this clearly understands that what comes after Dyn is a trait, because if we give it something else, like an auto, it says we can't find a trait named that. Output trait just has a couple of functions on it. We got name, we've got here. That's it. It's fairly straightforward. The problem is unlink. Why is it unlink? Is that really it? Holy crap. Thank you. Oh, okay. Okay, let's see. Oh wait, do we copy that into our impl? Wait, let's go to unlink. Let's make sure. Okay. Cargo catch. Missing name in implementation. Okay. So
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow. Oh, Alcaeus? Is that how you pronounce your name? Alcaeus? See, self. And we need to return back a string. And self.name. I guess that would be it. Why am I putting return there? Bad habits, bad habits, bad habits. Okay. What else is broken? Associated item not found. Okay, wait. Okay, so we need to fix main. We knew we were going to have to do that. So let's go find main and let's fix it. All right, so now we have... now we don't need to wrap... We don't need to wrap this, right? Right? Mismatch types. Let's find it. All right, expected reference found struct output auto new. Okay. Expected struct standard box found impl output. Oh, we need to wrap it in a box. Wait, what line number is that on? 193 of mixer. We need to wrap you in a box. Trait bound impl output. Uh-oh. Trait bound and impl output. Output is not what? What does that mean? The trait output is not implemented for impl output. That makes no sense.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, BK. Okay, so what is this? What is this? That makes no sense to me. Because isn't that exactly what this says? That output must implement this? The trait output is not implemented for and impl output. Is that this whole thing? Is that... Wait, what? So that the type... Adding an explicit lifetime bound. Okay, so is that our issue? Is the difference between like this? Oh. I'm just like typing whatever I want. Cargo check. We've got new errors. Expected 1 of 8 possible. Okay, so that's not the way we want to go. Okay, what are we complaining about? Add output, add output, add output. So that needs to stay that way. So what is our other error then? The trait bound impl output is not satisfied. So why is it not satisfied? Let's go look at our output. Okay, we name. Return string. All right, link, self, pipeline, audio, video. Link, self, pipeline, audio, video. Okay. Unlink, self. Returns back a result. So why is that not satisfied? What are you pointing to at? Let's see. Well, no, because in the insert, right? we're expecting this is inserting into our outputs hash map, right? And that should be a box, right? So it should be expecting a box though, right? The problem was with the error thing. What do you mean? Because here, right, this won't match because it expects it to be in a box, right? So expected struct standard boxed box. And we found an impl output. Say. So it wants us to do that. I don't understand what this is saying at all. What is it saying? What do you mean? The trait output is not implemented for. Let's remove this for a second. What happens when we do this? Does it build? Okay, so we have some other issues. Let's see, for each source pad. Cannot move out self-name, which is behind a shared reference. That's on line 45. Right, and we want to just do clone, right? Okay, so that builds. So our issue is here. So we know it must satisfy those trait bounds because otherwise that would have failed. So it has something to do with the way we're sticking it in this hash map. And we can't do any of this stuff. I don't understand what this means. Let's Google. We're just gonna take that part of it. And let's Google it. Let's see what the Google says. What does it mean? I swear, every time we go to refactor, it always takes like significantly longer than I think it's going to. Well, yeah, so that's what I thought too, but if we come into the mixer, in here, so are we doing like a to owned on it? Is that what we're doing? No. All right, reference to something that implements trait is not the same thing as trait object. But how is what we're doing different than anything else? Rust hash map of items that implement trait. Okay, so this is the same person doing the same thing we were. Where's bar? Oh, so they're actually taking their type and boxing it and putting it in there. Hmm. So they have... Okay, that's their just trait. What's their hash map? So they're doing a box element. Hmm. So should we really use an enum and then use the trait on the enum? Could we do that? Let's try something really quick. So what if we had an enum, pub enum, I don't know, we'll call it an output. We'll think about this. And let's say we had an auto, right? And in it we had an auto, right? And now what we learned earlier, I don't know, we'll call it link. So we learned that we could do now, because self would be the enum itself. So we would still have to match on the type, right? The easiest solution is probably to just change the parameters to be a box dyn 2. So then we would have to, then inside of our main, we would also have to wrap this in a box, right? We would have to do like box new, right? Something like that, right? I mean, I suppose we could also just return back a box, right? Here. Like a box. Is that what we want to do? Then we wouldn't have to worry about wrapping it here, which would make our implementation a little cleaner. Like this. No, so we just end up moving the problem somewhere else. This is where I start losing my knowledge of Rust here. Wait, we want. And we're saying we want a box. We want a box dyne output here. Does that work? What? Cargo build. Expected struct standard box found struct output auto. Store this in the heap calling box new. Isn't that what we're doing? Oh no, because I just put this in the wrong place. Right? Yeah, so we still have the same issue here. Oh wait, because this is a reference? There we go. There we go. There we go. Okay. Huh. Huh. I think if I smoked, now would be the time for a cigarette. That was rough. Okay. So I guess we should go ahead and do the same thing here. So should we require this to use the box? I wonder if we should just return the box. Like, let's try it this way real quick too. Let's Where's our new method? What if we just return back box? Time. Output. Okay. So let's go this route. Then let's implement the RTMP one. And then the other thing you could have done is casting to box dying. Not sure what you mean. So let's implement the RTMP one really quick. And then we'll also implement traits for our input. And then we can start worrying about our link and unlink. But then you'd have to completely unnecessary generic, which would bloat code. Okay. So here we need to go into our RTMP and start getting. So we don't need any of this. Set it, enter video. We don't need that. We don't need that. We don't need any of that. We don't need that. Okay. So let's go into let's implement our box here again too. Output. Okay, so there's our new. Let's go up here for our impl output, right? And we'll put that down here. All right, so that's implemented there. And we've got all of this logic here. Add elements to pipeline. Wait a second. Audio enter source, you go away. Have you done it like thing as box dying output? Oh, I remember using as for some other stuff. Okay. We're gonna take all of this out and we're gonna move this into our link function. And we need all of this stuff too. Wait, no. Okay, so this is adding video, so let's just comment here. Video. Okay. And now we're gonna link them. We're gonna have to fix all this, but this is our audio. Okay. All right. We're gonna have to come back and fix all of this because this is like a whole other world. Okay, so now we need to we don't need the pipeline. Wait a second. Oh, I take that back. We do want the pipeline. We do want to save the pipeline here. Because we are going to use this later to unlink things. So even inside of here, we want to set pipeline. Cannot find value pipeline in this scope. Oh, because it doesn't go in there. Oh, is that going to yell at us because we don't supply pipeline? Is it? That's a lot of errors. A field by this name exists in self. Alright, hold on. So we need to, in link, link is where we want to set self.pipeline equal to pipeline so that we have it for later. We're going to do the same thing inside of this link because we are going to need this later. Okay. All right, here we go. So now we need to start adding all of these elements. So we have our pipeline. I'm just gonna say video scale. Convert, scale, rate. What else do we have? Caps filter. Caps filter. Then we have x264 encode, x264 parse, x264 encode, x264 parse. I know that we have an FLV mux. I know that we have our RTMP sync. We're just calling it QSync video sync. Okay, so let's call it video sync, and then QSync. You need to initialize everything at once. So does that mean that pipeline so that means that pipeline needs to be an option, doesn't it? Well, not here. Here, it needs to be an option, right? Because I'm not going to know what the pipeline is at first. Here, that would need to be an option, and that would mean in new, where are you? For auto, I need to set pipeline equal to none. And I guess I would need to do the same thing here. Pipeline needs to be none. And we need to return back a box. Get in the box. All right. Import output for RTMP. Okay. So we've got a lot of stuff here. We're probably going to need to do some naming here too. Let's see, with, we just want nothing, right? Yeah. There we go. If a field is uninitialized until one function is called, it's usually better to split the struct up into one where the field doesn't exist and one where it does, where one gives the second. What? H264 parse. H264 parse. Okay, and then here, this is H264 parse. Okay. Okay. This is a really big freaking struct. Ugh. Your stream keeps freezing on your side? Am I dropping frames? I can't even see. Small red text. Okay, so now I guess we just need all the audio. Audio convert, audio resample. Oh, let's undo that. Let's copy one. Audio convert, and now let's do, I don't know, sample. Or resample, encode, parse. Audio resample. AAC or audio encode. We need to fix our naming conventions here, but we'll do that once we kind of get our refactoring done first. Audio encode, AAC parse, audio queue. Okay. So now we need AAC parse. And then audio queue, right? Okay. I'm gonna rename all of these things later. Audio convert. Because this is just sort of hideous naming conventions.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Shota. Okay, so missing fields. All right, so we need AAC.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks so much for the follow, Gene Blue. So we need AAC parse audio convert. Okay, AAC parse. We need audio convert. We need audio resample. Black Warrior, thanks so much for the follow. We're starting a trend. Audio queue. Audio queue. All right. I'm sure we're missing more. Are we? We should be. What do we got going on here? Okay. Missing audio ink. All right. Audio ink. This is going to drive me nuts because this is such terrible naming conventions, but I want to get this, like, the major part of the refactor done to see whether it works first. What is all this? Oh, this is all in the linking. Okay, this is fine. We knew we had to get here. Okay. So, let's see. Pipeline. We need to. We're just to replace all of these. Substitute ampersand with ampersand self dot. We got an issue with video queue, but we'll come back to you. Okay. Mismatched types. Oh, right. So this is some. Okay, what is this? No field video queue. Okay, so we are missing something. Where's the video queue? Sit. Video queue. Sitting after FLV mux. Okay. Video queue. Okay. Hey, Thamar, what's going on? We are refactoring all of this yet again for like the 16,000th time. Okay. Build? Are you gonna build? Please build. Oh, we just missed another instance where we need to wrap this in a sum because this is now an option. What? Wait a second. Huh? Why did that work in the other place? Cannot assign self pipeline, which is behind an and reference. What did we do for the other one? Self dot pipeline. Why does that work there? It works here though. The same function. Is it complaining in both places? 213. Oh, okay, it is in both places. No. No, it's only in that one place. What's the difference between the two of them? Because here we have this, right? And our link function does not take a mutable self. So then we come up here, right? These lines are identical, and we don't have a mutable version here. So why does it work in one place and not the other?
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, McCurdy. Not a programming question, but what mail client do you use for exchange emails? I cheat and I use Outlook on another device, or Outlook Web Access. So why? I'm slightly confused why this works in one place and not for another. Yeah, so unfortunately, it is almost 2021 and email still sucks on Linux. I'm kind of bitter about it, to be honest. Okay, it looks like it does fail in both places. So we need a mute self here. And let's see, link. Let's find all of these. I don't know whether we need that. So we need a mutable self here. And we need a mutable self here. Okay. Hiri. I don't think I've seen that one yet. Output link cannot borrow as mutable. Oh, right, because in the mixer here, Cannot borrow output as mutable. How do we... This is where I get like kind of confused. So is it an and mute box self? And now what are you complaining about? Found mutable reference. Help store this in the heap by calling box new. Isn't it already in a box? Do we have to rewrap it in another box? Box new. Ah, so we broke this again. All right, so let's get rid of all this nonsense. So here's what we're gonna do. We are just going to come up here. Where's our trait? Nope, that's on input. On output, where's our trait? We're just gonna take a regular self. No, because we might want to modify ourselves. We do want a mutable self. This box thing is gonna be the death of me, I'm telling you. Found a mutable reference. So how do we get... Oh, I guess if we do an as ref, we can downgrade it. Does that work? And then we wrap it in a box new. Box new. Work? No. So we don't want an as ref. We want a to owned. How do we switch that? There's bound to be a way of doing what it is that I'm trying to do here. Well, here it shouldn't matter, right? If you just pass me that. Then I should be able to do a self.out and just pass this in here, right? Hold on. Cargo check. Wait, how do we have a mutable reference here? That should not be a mutable reference. On 190. Why is that a mutable reference? Oh, duh. This needs to be mutable. This is not supposed to be mutable. Okay, now this is going to complain because it wants output to be mutable. But we could just do output, let output equals output dot as mute, right? Can we do this? No. As it is declared as mutable. It does need to be mutable. All right, I'm lost. How do I get this to be not mutable to go in my box, but mutable so that I can call link on it? Let output mute. How do we get it out of the box? We have to unwrap it, right? What's the method set on a box? So it automatically like unwraps the box already.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, SimDK. So, does into work? I feel like I'm just trying stuff until it works here. So that's that, and that's not going to work. Yeah. Okay, how do we do this? I feel like I'm missing something. So we know we need I almost feel like we should have just stuck with the enum approach. I mean, the code inside was kind of a little crazy, but this is even more wild. I guess I just don't understand the generic side of things. Well, not fully generics, but more polymorphism inside of Rust. We need a T here, but we need an and mute T here. And we can get this here. Found mutable reference. Help store this in the heap by calling box new. We tried that. It's kind of hard to tell if you should be using trait objects or not just from this little code, but usually newcomers tend to overuse trait objects and underuse enums. Well, so we started a little refactor here where we had enums, but there was like these giant match statements, right? Because all of these, the types that we want in here, we want them to all have the same method, right? Link and unlink. So I feel like, you know, when we think about normal object-oriented programming, like a polymorphism type approach here makes the most sense. The most sense, right? It just doesn't seem to work that way. So this is the part that confuses me. Well, that's fine, right? Because inside of main, we can fix this and tell it, hey, pass a mutable reference, right? That one's the easy part to fix. It's the other one I don't understand. So if we go into our mixer here and we put this in a box, this will complain, and I'm not 100% sure why or what this issue is. So do we need to back this all out and then go the route of the enum again? Because, I mean, realistically, the mixer shouldn't care. The mixer shouldn't care about the internals of it. Just that it can say, hey, here's your pipeline, here's your audio and video elements. I need you to link to them. So I feel like this is the right approach, but I can't figure out what the secret is to get this where I want it. There's got to be a way to convert between these two, right? Because we're downgrading it, right? If it's a mutable reference coming in, and I thought to owned was the way you did that. All right. All right, let's look at this. If we take the output, what do we have? Huh. So into should give us. Oh, okay. So this is if we were to say like let
we have a new follower.
Output equal, or we could just call it box dyn output, right? And then we could say equals this. Is that going to convert it? So, thanks for the follow, Sultan. What is this? Cargo. Oh. Because I always forget that. It's still an error. Yeah, so it doesn't know how to convert it either. Does as ref? Is this what we want? No. Trait dying output is not satisfied. Why? Why? What? Cargo. Check. The trait output is not implemented for and-dine. Why? So this gets us like an and-dine. Yeah, I tried that. You didn't like it. Why do you hate me, Rust compiler? I guess I don't fully understand what this is telling me. Try changing function signatures to mute output. That's what it is. So add output right now has the and mute. Oh, to just mute? What is this? Cannot find value output in the scope. Oh. Oh. Thank you, Savish Crab. Ah. I screwed that up. That this is saying that output is going to be mutable and not that I need you to pass me a mutable thing. Okay. So this is probably going to blow up on our main because we passed it like a weird thing, right? Yeah. So let's go back and fix main because we don't need any of this nonsense. Okay. There we go. Okay. Now, let's try and get an RTMP one in there too. Did we finish adding that one? Yeah, we did. Okay. Let's try this. All right. Function or associated not found in. Oh, that is because we renamed all of this. So this is really RTMP new. Okay, and that broke our pipeline. So we are stuck in a pause state, so let's go ahead and generate the SVG for that and see what happened. All right, we can close all of these tabs of desperation. All right, paused. Okay, so here's our URI decode bin. I feel like we have some... We need a better way to... Alright, apologize, everybody's going to have a hard time reading this for a second, but we need to back up a little bit. Okay, here's our URI decode bin, and this is our test sources. So these aren't connected yet, which is okay. I'm most interested in what happens after our compositor and stuff. So here's our video mixer, which is the compositor. So we have everything coming in. What happens after that? And here's our audio mixer. All right, we are going to our caps filter Q. Then a video T is going out to our auto video sync. But we don't end up connecting. So we have this whole RTMP part of our pipeline that's stuck here. And so that's our issue. We are not linking together. So let's go check out our output. Oh, wait a second. Let's check our mixer first to make sure. Okay, we are calling output link and we're passing in our T's. Okay, so let's go. Okay, so this is why. So we need to link our video to the front of this. And we need to, oh, that's not what I want. That's already added to the pipeline. We want it to link. And then we want to do our audio here. Nope, not in the ad, in the link. All right. All right, we're still stuck in paused. Why? What are we missing? Let's go find our... Alright, so here's our video T. And we are coming out to our auto video sync, which is the video you see pop up here. And then we are coming out to our video convert, which is going out to our X264 encoder and all of that, and then down into our FLV mux and out. So why GStreamer and not talk to FFmpeg? So FFmpeg, I looked around and I couldn't find really good bindings. There was really good bindings for GStreamer, And I'm not an expert on this stuff, and neither will some of the people who are working on it. And I feel like conceptually, the pipelining like makes a lot of sense logically to think about, and disconnecting pads and reconnecting pads. So I feel like just ease of working on this over time, the pipelining will be significantly easier. I could be wrong. I don't have a lot of internal knowledge of FFmpeg either. Okay, so where is our issue here? We don't have a negotiation error or anything. Do you have more familiarity with FFmpeg? Just out of curiosity, is there some benefits that you may know of to using FFmpeg for this? Or is this just more of a curiosity because, you know, people have different preferences for using things? All right, I know we had this working earlier before we swapped all of this out. Let's make sure that everything is connected. No, it should be. We were just looking at the diagram. Okay. So let's follow this through really quick. We're gonna follow it backward. Okay. So we do have our RTMP sync fed from the queue, which is fed from our FLV mux, which is fed from our audio and video queues, and it's showing all of these as playing, which is fed from our parsers and then our encoders. Okay. So we had this working, right? Before we started our refactor. So this should all work. We make it all the way back. What is this? Oh, this is our Syntel audio convert. But why is that not connected? Right? So our video mixer, we have Syntel video queue, and our video scale, which is coming from our test source. So it looks like our audio is disconnected. No, because our video from Syntel is also going to be disconnected, right? Yeah. Because we're in the paused state. So what am I missing? Let's try something really quick. I'm going to remove Syntel from here. And let's see whether we can just get our... let's try and debug it a little bit. Okay, so that does not work. So let's try... wait, what was I doing here? We'll leave that out. And let's send Syntel to the auto. So so Syntel works. Nothing works to RTMP though, even if it's the only thing. So we've got some sort of issue with our RTMP out. No, that's not true. All right, because this isn't going anywhere. Oh, no, I want that here. There we go. I have no idea how I just did that, but that's not at all what I wanted to do. Alright, let's look at source main. Okay, so we are playing Syntel, and we're playing it to RTMP. Okay, so our issue is when the auto sync. Okay. So our issue is when we have more than one output. Let's try something here. I think I called it learn backup. Let's see what happens if we add more than one RTMP output. Backup. Is our issue multiple outputs, or is our issue specifically trying to find... Okay, so this feels more like a negotiation issue, which is something I'm still kind of trying to get better at. So in theory, we have this one. And if we open this up and we say backup, backup. Okay. So we have this going to 2 RTMP endpoints right now. Okay. So this is where it starts getting a little beyond my knowledge of GStreamer, but, well, it's probably far beyond my knowledge of GStreamer already, let's be honest. So the issue seems to be if we can get this to play using multiple, right? We can get it to play to either of them. We can also, and we'll test this too, we can get it to play to multiple outputs of the same type. Then this would seem to me like some kind of negotiation issue of trying to find a format that works for both. Well, that did not work. That is still very much in the paused state. Is it a race condition? Okay. Let's see. Why would we have two? Why would we have an issue with the two of those? Um. All right, so we've got a few issues here. So we still need to finish that refactor on our input so that we have a trait for that as well. So maybe I should go ahead and do that first, just so that we're kind of following suit. Then we also need our unlink functionality, which I imagine if we just remove them from the pipeline, will that detach them? Guess here's an easy way to find out. Let's go implement that on our output really quick. So we have our add many. Add many. So if we were to take this here, right? And go into our unlink here. Self.pipeline. Is there a remove many? I thought there was a remove there. Let's go to where we did our other one. Remove. It's just self remove. Do we have to do it for each? Self dot pipeline dot oh, we need to unwrap it first. That's why. Unwrap. Then it'll have remove many. Okay, that's what we want. Unwrap. Remove many. We're probably going to have to do some other stuff here to do cleanup, but let's see what happens here when we just remove many. Self.pipeline.unwrap. All right, we need to return. Okay. Cannot move out of self.pipeline, which is behind a shared route. Wait, what? Alright, I'm not entirely sure what this error is. Cannot move out of self.pipeline, which is behind a... Let's go to here. This typically has better... Gotcha. So we need a self.pipeline.asRef. Okay. So we can come into our main here We can add these outputs. And then we could say mixer.remove output and give it auto 2. We do need to make sure that, yeah, remove output. Did we remove that method? All right. Okay. Remove input. Unimplemented. All right. Okay. I don't think we're gonna need this. So, okay. So really what we want here is name and str, right? And then we're gonna have the same thing for here. Wait a second. Oh, wrong one. There we go. There we go. Move output. So I must have deleted that because we did have a remove output method here. So we need to check to see if outputs contains key. If it does not contain the key, then we need to return back. All right. Doesn't exist. All right. Okay, so then if at the end we are going to do a self.output dot, is it remove? Remove, okay. And then we're gonna do the same thing. I guess if we reach the bottom here, then we're good, right? The trait bound standard option none error is not satisfied. What? Am I using the wrong method? What's the difference between a mute or a remove and a remove entry? Thanks for the follow, Chilaxathor. Large data bank, welcome, welcome, welcome. All right, we got to give large data bank a shout out here. It works on a very, very awesome distributed database called CockroachDB. If you have not seen it, he codes live, working on it. If you have not seen his stream, it is amazing. He does Go, and he's not struggling with Go like I am with Rust.
It appears we have a new follower.
Thanks for the follow, Dusty Posy. So, we are struggling through some interesting things with both GStreamer and my knowledge of Rust at the moment. So I'm working on the RTMP streamer that we talked about the other day when I came in your stream. We're doing a bit of refactoring right now. I guess if can I just put unimplemented here to get that to work? Let's see. We'll comment all this out for now. Okay. So, ooh. Oh, it's panicking at not implemented because I added this. We're like just testing a bunch of stuff right now. So this is not working with two of those sources, but we've got a couple of bugs. Like if we try and open up one player here and one RTMP, it doesn't flow right. But we can open multiple RTMPs. So we're kind of working through a couple of kinks with it, as well as trying to finish out a refactor that we've been working on. Okay, so that's yelling at us because we didn't finish implementing this. Okay. So we need to self.outputs.get. Do we need it mutable? I'm going to assume that we need it mutable. And we're going to pass in name. And we should be able to say unwrap. And this will be our output. Oh, the stream becomes laggy when I run that? I mean, it's quite possible, right? Because then my computer is both encoding my own video stream as well as encoding the stream that we're messing with. So I wonder whether I should really set up another computer to do this on. So this is NeoVim. I'm running the new 0.5 nightly. It's probably a few days old. I might have some local changes, but you can find all of my NeoVim configs on GitHub. So a lot of what you're seeing is like, this is all airline that you're seeing up here. If I open up these things, you've got like dev icons. I don't think he's in here, but check out Tej's stream. He does a lot of streaming on NeoVim and some of the plugins he's using. So like there's this new finder. Oh, we're gonna back up a little. Oh, did I get trapped in there? There we go. So this is a new telescope plugin that Tej is working on. Sometimes I do that. I end up getting trapped in these windows. All right. Do an H-top just for funsies. You got it. Let me bump this font back up too. I'm actually kind of surprised how much CPU is being used right now, considering I'm using the NVENC encoder. I need to go through here and look at what all's... Alright, so... Oops. Wait. Okay, so that's our box. Okay. So... now we have our output. We need to call output.unlink. And then we should be able to self.output.remove name. All right, what is this error? Oh, you want to, okay, I got you. Oh, we need to fix this. The trait standard error is not implemented for standard option. Do we just get an remove returns back an option? All right, hold on. Let me fix this real quick. What does this return? Oh, okay, so it must return back the value that it removes. Okay, that's fine. All right, what were we doing? Oh yeah. We're h-topping, and then we run it. We're panicking here still. Okay. All right, here we go. And we have liftoff. Oh, it's stuck in pause state. Let me remove this. And let's remove the second one. Let's just do the one, because we know this will work. So now we should be out of like our broken scenarios we're still trying to debug. Okay, here we go. Lift off. Is the CPU usage really less while this is going on? Wait a second. How does that even work? You all noticed that, right? The CPU usage literally got better when I started doing this. Yeah, so there is a version of Edge on Linux now, yeah. And I am playing with it. Hey, and for everybody who's been watching my stream, while Pretzel Rocks crashes over and over again, it has not crashed one time in Edge. But it was crashing, I don't even know how many times, in Chromium. Okay, so where were we? Large data bank. Have you seen the bot we've been building here with all of with Go? I mean, it's not my best Go programming, but that's mainly because we just rush through it because we want features done. So we've got a whole bunch of stuff. I've got a bunch of sounds and stuff like that you can play. That's all written. All of these hue lights, so we can say hue, I don't know, blue, electronics, and that'll back there, and we can do hue, pink, desk over here, party, and it'll start like rotating through random things. We've got it so it blinks the key lights. And I've been building it in sort of like a modular fashion where you can implement actions, and then your commands are just a JSON file that specify when this command is ran in the chat, then really this list of actions with these parameters should be ran. And then it has a way of mapping additional arguments in the chat to arguments of the actions and things like that, so that you can kind of invent new things without having to write code for all of it. So it's been pretty fun messing with it all. I've got a bunch of other ideas for controlling Vim and things like that we haven't got to yet, but okay. So our remove is broken. Let's figure that one out first. Oh, we need an expect here. Failed to remove output. Okay. I've seen some people put light changes and such under channel points, which I think is kind of fun. Yeah, we started our own economy here. Right now, you just earn points for communicating in the channel, and you never spend them. So, but the bot has the ability for points to be used for things if I restrict them that way. And then there's also the ability to give people props too. So I can say, you know, and that would take 5,000 points I've earned and give it to you, and then you can spend the points and stuff like that. So we can kind of create a thing where it's not based on whatever Twitch says you get points for. So for instance, I have the bot joining multiple channels, like other coworkers and friends, and you also are earning points while you're like hanging out in their channels too. So we haven't come up with all of the ways you'll earn points or can spend them, but I thought it'd be kind of fun to create like a new economy that doesn't depend on just whatever reason Twitch says you get points for. Like if you solve a problem for me that I've been fighting with for like 30 minutes, then I want to just give you all of the points. All right. So this works. So why did it crash? Why was your comment censored? I don't see anything in auto mod. Thread panicked at not implemented on output line 63. Wait a second. Come now. Oh, because we don't have it in here. Gotcha. Okay, so we just need this. We implemented it for our RTMP version. We didn't implement it for this. Wait, what did we say we needed? As ref here. Oops, other way. Oops. There we go. Mismatch types. All right, because if we hit here, then we need to return our unit struct, and now we shouldn't have a problem here. Nixative, how's it going? Oh, look at that. So that other output got removed. Yeah, I like the idea of the altcoins, right? Like, I haven't figured out exactly how it's all going to work, but I think it would be cool to kind of create like a network of people. And if people come to your channel and help you out, then they should be able to spend them in this channel or your channel or wherever. I kind of like the idea of that, where we're not limited to just I want to be able to give people extra coin. Okay, so we now have that. We do need to finish our refactor of input. I guess we can remove this whole... We don't really need this whole function anymore. That's all committed. Okay, so we need to finish our refactor of our input too. Thanks for the follow, Hux. So we're getting there, Nixative. I aborted the mission on the whole intersource stuff. I don't know whether we have a diagram of that. We have, oh, that's that one. So we had this whole idea here where basically there was a intersync here, or an intersource on this side and an intersync here. And then all of this became its own pipeline. And then same, if we scroll over here on the output side, we had an intersource on this side, right? And an intersync on this side. And it basically allowed for these to be like pipeline, pipeline, pipeline. And then we would name the connections between them. And GStreamer like basically is like, oh, this is the same channel, I'm going to connect them. However, I find that like all of my pipelines just don't work. They're just these really weird bugs, and you know, guaranteed I'm using it incorrectly. But we were kind of spending too much time on that, and so the thought here was to just remove all of that, which is what we're doing now, and just manually connect them so they become just one big pipeline. And then later, when I have more time, I will look into how to refactor all of that and use those. Maybe if I meet a new friend that has more GStreamer knowledge than me or something. Which wouldn't take a lot. I don't have a lot of GStreamer knowledge. Okay, so let's implement our trait on this side too. So it's basically the same exact thing, right? Input. Okay. So there's our trait. And this is public struct. This is just going to be a URI input. And here we're going to implement our URI input. And we're going to get rid of link. We need to come down here. We're gonna impl link, wait, input for URI. There we go. All right, we move link down there. We also need, oh, we don't have unlink. Okay, so we're just gonna change from URI to new. And then we need our unlink function. Pub function. Wait, no, we don't need the visibility specifier because this is the trait implementation, and the trait itself is public. So function unlink, and we need an and self, and that's it. And we're going to return back our result unit struct box dine error, right? Unimplemented. And we might have to do some magic later, because so far all of our messing with the pipeline is before we actually start it up. Expected trait. What do we do for... That's right. Expected trait found type error. Oh, because I'm trying to wrap it in a box, and that's already our thing. There we go. Yeah, I played with the my own custom errors inside the mixer too. So I may swap that all out too when I have some of like my own custom errors that I might want to return when I start trapping them and stuff. Doesn't have size known at compile time. Oh right, because we now need to go into the mixer, and this is going to be a box dyn input. And then that also means for our new function here, we want to return back a box dyn input.
We have a new follower.
Thanks for the follow, Zaner4. Okay. Let's see. What do we got? Cargo build. Whoa, whoa, whoa. We blew some stuff up. Input method, not a field. Oh, right. Okay. We're going to need to fix all of those. Okay. So this is same issue. So outputs.insert, right? No, we want inputs.insert. Did we wrap that in a box first? No, we didn't. Okay. So here we need a mute input, right? And this should be impl input, right? Name. And there we go. All right. Got a type mismatch. What'd we do? I didn't do that for the other one though. All right, let's look at this. What's the difference? Oh, did we give it a mute self? I'm gonna copy this. All right, so what's the difference here? Oh, right, because we never changed this. That's how we did it before. This we changed to be a box dyn input. And I still don't claim to be an expert on what all of this means. My rough understanding is that because we can't know how much memory this consumes we can't put it on the stack. So this box is like a wrapper to say, hey, this is gonna exist on the heap. Ooh, all right. Okay, we have more errors than I thought. Pub not permitted here because it's implied. All right, because that's same thing. This is on a trait. 115 type in trait differs in mutability. Missing name and implementation. All right, let's just steal the name implementation from here because it is literally the same thing. Are you streaming today, Large Data Bank? All right, expected struct box found. Oh, right. Okay. So that is on line 101. We have this new. We forgot to wrap that in a box. Okay. And this is a mute self. Okay. One more. Right. Okay, so now we just need to fix our main where we build this. We want a URI new. Okay. There we go. Before I forget, let's go to our mixer. Oh, we need to implement this really quick. So two things we need to do. We need to find where we implement ball. We're going to put black there. Okay. And now the other thing we need to do is go to our unimplemented here. And we need to call, I guess we can just literally copy this whole function, right? No, not that one. Remove output. Where's remove output? Because it is quite literally the same exact function. All right. Input. All right. All right. Input with name doesn't exist. Input. Input. I know I could have done a substitution in Vim, but sometimes you get like momentum going with your hands and you just... All right. No field inputs. Okay. Associated function is never used. That's fine. Okay. So this gets us about where we wanted to be. For our refactor anyway. And then I guess we get into let's remove some of these comments that we may have. Where's our whole big to-do block? Oh, it's in the mixer. So we haven't got to audio and video only. So we still have issues with... We still can't fix these ones yet because we haven't got the two working together yet. We still need to leave that. I think we sort of figured this out. We probably need some tests here still. If you have a couple of videos or something like that you want me to throw on, we can try to use that. We're going to remove that. I'm going to leave that there because it's related to this up here. And we haven't even got to that. Okay. Let's commit this for now. Refactoring out enter audio or video source audio source / sync. What do we want to call that? Filtering out inter sources and syncs to create a single pipeline. This seems to be less brittle. We'll return to this approach later. Okay, so we've got that little bit of a refactor done. Do we have anybody who is new here today or has just popped in before and is not really up to speed with what we are building? I am more than happy to kind of take a couple minute break from this and walk through anything you would like to know about what this project is, what the goals are, how it works, details about GStreamer. If you want to kind of understand how the video and audio works and how it's all demultiplexed and what all of those terms mean, we can walk through some of that. I probably do it about once per stream anyway, so. I think the next phase is going to be a little trickier. That's going to be debugging pipeline issues. And I'm not entirely sure I'm going to know the answers to all these questions either. Sure. So what you're kind of seeing here, I can demo a couple of examples. So we'll just sort of like walk through what the code is doing so far. So here, it helps probably to look at this diagram. Okay. So what we are working on is when we talk about an output, we're talking about over here. When we talk about an input, we're talking about over here. And then the switcher, the mixer is a component of the switcher. Okay. So we can talk about how all of this stuff works too. But when we look at the code, you can see here, I create a mixer, we're naming it. There could be many, right? So we may control multiple channels or stations or whatever you want to call them, creating linear feeds. So maybe this is Twitch, right? Maybe it's Twitch and YouTube, and then you have some other website that's managed by another mixer. Now, we're adding an input to it. We're just calling it Syntel. That's because that's the name of the short video created by Blender. And we're passing that as an input. Do you want to try to get it to run on a background thread and send commands to that thread? Yes. So once we get sort of the pipeline stuff working, this will all be wrapped by a web API that you'll be able to curl, and we'll have a front end for it where you can visualize it, see what's in the mixer, see what's pointed where. We're going to build out all of that. Right now, we're just sort of working on the pipeline and mixer. That way we can start working on how do we control it remotely. Okay. So then we have outputs, and here you can see we're adding multiple outputs, removing them. And ideally what we're going to allow you to do is swap these out on the fly. So you could be, splitting off and going to Twitch and YouTube and then just say, you know what, stop sending it to YouTube. And same thing, we want you to be able to layer on an input. And eventually we'll even be able to get down to doing like picture in picture and things like that. So which we could do. We could just do a fun little demo right now and change up our compositor so that we could say, hey, display picture in picture. Okay, so here's us just removing one, and then down here we're telling the mixer to start playing. Okay, so we do have some issues. So if we try to play to more than one audio and video sync, we are getting an issue. So we've got this here. So this will play this video to locally. Now we can go through and we can change this up. And I'm just going to pull this up here. And now here, what we'll do is we're going to send this. We're now adding two outputs. We've got two RTMP URLs here. And so now we're going to send this out to multiple RTMP endpoints. And we won't see it locally here right now. But if we come over here, we've got this one here. We're just called Learn TV Transcoder. And there's our video coming. But we can also go over here to the one that I've labeled backup. And so this could be YouTube and Twitch. It's just two RTMP endpoints. They just happen to be Nginx running RTMP module running out in Azure somewhere. But so there is our switcher. So we do have a couple of issues that we're trying to resolve right now. So one of which is that where we can't have more than one of those. We also have this issue where if I try to send the output to both that audio sync or auto sync and RTMP, oh, that's the remove. That's the remove. What are you doing? We don't want to remove it. All right. Now this is going to attempt to play it both locally and out there. Wait. There we go. Oh, wait a second. Oh yeah, see, so something happens here. So we end up just stuck in this paused state. So this is one thing that we do have to debug. And this is likely just some sort of negotiation issue where the pipeline is unable to kind of figure out a format that works for both outputs. And so we might have to put some like caps filters or things like that in place in order to get that working. But that is basically where we're at now. It's been a little bit of a learning experience, both on the GStreamer side and on the Rust side, but I feel like we're starting to make progress here. And there's going to be some weird issues, right? I've got some notes here of things that I know are going to break our pipeline when we try to like switch it on the fly. But yeah, if you're not familiar with the way GStreamer works, if we look at like a working pipeline, everything is an element in the pipeline. And then you have source elements, and source elements have source pads. They produce data. So this is an HTTP source that produces data. And then we'll look at this in a second. And then you have if we go all the way to the other side, you have a sync element. So this is how the audio is getting out. Oh, this is the inter audio, which we're not using anymore. But so that has a sync pad, data flows to it, right? Then you have filters. Filter elements have one or more, they have at least a sync and a source. But if we look in the sense of like a T can have more than one. So where's our paused one? I know we have a T here somewhere. Where are you? There you go. So here's a video T. So we see data come into the sync and then come out to sources. Now, in addition to that, pads have capabilities. So these pads have a video XRAW capability, and then we can set specific formats, widths, heights, frame rates, things like that on it. Or the pipeline will try to, later elements will try to suggest capabilities to earlier elements in the pipeline, and then the earlier elements in the pipeline will decide what the format's going to be. And so that's sort of what's flowing there. And if you're interested in any of these things, once you have GStreamer installed, you can do like a GST inspect, and then we could say something like H264 or X264 inc. That's our H264 encoder. And here we can see what the pads are, what the capabilities of those pads are, and what the individual properties are that we can set on here. So another example might be that video test source you saw with the bouncing ball. That's this element. And we can see it just has a source pad that data is produced on. And if you look, there is a pattern property, which is the one you saw me update, from ball to black. Now, the really cool thing about it, let's see, and we can talk a little bit about how HLS and RTMP and stuff like that work too. Can you use random Twitch stream as a GStreamer source? Yeah. So here's I'll do a quick demo too of how useful GStreamer is even outside of code. It's ridiculously useful to do stuff like this. And it's one of the things I like about it over FFmpeg is it's really intuitive. I'll demo that, and then I'll give everybody a quick crash course on how video works, and then you'll be up to speed with everything I know. Okay, so you saw me do that video test source, right? So we can actually there's a GST launch, and now we can actually build these pipelines just in the shell. And if you're familiar with Unix commands, then you can do it too. So we're going to take a video test source, right? Now we want the pattern to be ball, okay? Now we're going to pipe it, and obviously Unix, they stole the pipe, so we get exclamation point. We're going to take that, and we're going to send that to a video auto sync, and that just tries to find a way locally to play it. Wait, auto video sync. I will forever. And then boom, we have it playing here. But wait, we want to send it to RTMP. Well, RTMP is a little trickier. So we don't have any audio, but we can take this, and now we need to encode this. So we need to send this to an X264 encoder. Then we need to send that to an FLV mux, and we'll talk about why this is. And then we need to send that to an RTMP sync. And then the location is RTMP. Here, let's just steal it from here. All right. And now, if we go to our preview, somewhere, there we go. Now we have our bouncing ball going to our RTMP server. And now we could do this the other way too. We could have, instead of a video test source here, we could have actually fetched it. So we could decode this and send it the other way. Does that make sense to everybody? And so it's just a really cool way of looking at this. So now, as promised, I will teach you all how video works. So let's bring up my diagram here. Okay, so when we first start talking about video, the first thing we have to talk about is transport. So how is the data being transported, right? We could be reading it from a file. We could be reading it from HTTP, or in this particular case, we're talking about RTMP. Now, RTMP is just a method of getting the bytes from one place to another, right? It only supports one container format, but it's not as crucial to this. It's just understanding that RTMP is the transport stream. Okay, so once we remove how we're getting the bytes, we have a container. And not a container like a Docker container, but if you've ever seen .avi, .mp4, .mkv, all of these things, that is a container. So it does not define the codecs that are used. Certain containers support certain codecs, so you can't automatically interchange them, but it tells you nothing about what that is. So inside of that container is several streams that are multiplexed together. And you typically in a movie would have at least one video and at least one audio, but you can have more. There's nothing preventing you from having, different languages. You could also have, closed captioning, things like that. So a container is a bunch of multiplexed streams together. That's it. So An FLV container, which is the flash video container, which is the container that RTMP uses, you typically are using H.264 for your video and AAC for your audio. Those are codecs. That's how compression is done. And we can get into kind of like some specifics about video and audio compression. But when we're talking about that, a codec is how you encode or decode the data stream, right? Because video data actually would take up terabytes and terabytes of data for just a few minutes if it wasn't compressed. We can get into kind of I frames, B frames, P frames, and how all of that's done. But unless you're implementing it, you don't have to be too aware of it. So all we need to know is we have a container. Inside of that is audio, video, and those each are encoded in their own codec. Okay? So how all of this stuff works is you bring the input in, you first demultiplex it out into your audio and video. These are still raw bytes. Then you're going to send those into your decoders. So in this case, we said 4 bis, but it could have been MP3, right? And then VP8 is a video codec. Now we're splitting that up and then teeing it out so it could go to multiple places. And then this is our mixer that's deciding to use a compositor to layer the raw video frames and things like that on top of each other. And then when it comes out the other side, we're going to re-encode the video, re-encode the audio, and then we're going to multiplex those streams back together into some container. This could have been an MP or an MKV container and going to disk too. Does that make sense? Oh, and I sent a couple of links too. Is it video intro? Yeah, there we go. Those are some cool links if you're interested in learning how all of that stuff works. I know I went through that really, really fast, but does that make sense to everybody? Does anybody have questions about any of the individual pieces I just kind of ran through? All right. I am starting to lose my voice. I streamed for, I don't know, like 12 hours yesterday because I was working on stuff. I might break away and get something to eat for a little bit and then come back. So I think I saw Prime on too. Let's all go raid Prime. Let's go harass him for his bad audio yesterday at VimConf. Let's see. I can't type. All right. I will definitely be back on. See, I'm already losing my voice. I'll definitely be back on in a little bit. I just need to kind of get something to eat. And I've been at it for, like 4 hours today? 12 yesterday. And give my voice a second. And then I will be back. As always, thank you all for hanging out. This is a ton of fun. I'm super excited I get to do this stuff. Headphones? You're talking about? These are, let me pull up a link. Come on. Give me a link. There we go. There you go. So yeah, they're the DT770s. I like them. They're really comfortable to wear for a long period of time. All right, let's do it. I'll be back probably in an hour or two, something like that. Thanks everybody for hanging out. I'll be back in an hour or two if you're interested in hanging out for more of this.